Let's be honest, when you hear the word cyborg, your mind probably jumps straight to the movies, right? A metal skeleton from the future, maybe a super soldier from some sci-fi blockbuster. And for decades, yeah, that's been the story. But today, we're going to peel back that fiction and look at the reality of neurobionics. And it's a reality that's, well, it's quieter, way more profound, and, in a lot of ways, much more human than machine. So let's dive in and see how this incredible technology is actually changing lives.
So on one hand, you've got the myth, these unstoppable warriors, more weapon than person. But the reality? It's something else entirely. See, this isn't about creating superhumans, it's about restoring humanity. We're talking about technology that doesn't just replace a limb, but brings back one of our most fundamental senses, the simple feeling of touch.
And this quote, this right here is the heart of our entire explainer. We've actually crossed a major threshold. Modern prosthetics are moving way beyond being just simple tools. They're becoming truly integrated extensions of the self, restoring not just movement, but the feeling and the instinct that goes with it. So how on earth is that even possible? Well, it all starts with sensation.
You know, for over a century, a prosthetic was basically a silent partner. It could grip something, sure, but it couldn't feel it. An amputee had no way of knowing if they were holding a hot coffee cup or, say, a delicate egg. The whole revolution in bionics really began by tackling this exact problem. How do we give feeling back to an artificial limb?
The key breakthrough is this remarkable surgical technique called targeted sensory reinnervation, or TSR. I know, it sounds super complex, but the concept is brilliantly clever. What surgeons do is they take the nerves that once went to the missing hand, for instance, and they give them a new job. They reroute them to a different patch of skin, like on the chest. But here's the thing. The brain is still wired to think signals from those specific nerves are coming from the hand.
Let's break that down. It's basically a three-step process. First, you have that nerve rerouting we just talked about. Second, when the prosthetic hand touches something, sensors in the fingertips send a signal to these tiny stimulators placed right on that rewired patch of skin. And third, and this is the magic, the brain feels that little buzz not on the chest, but as a distinct sensation in the phantom hand. The brain literally learns to feel through the machine. It's incredible.
And this just brilliantly illustrates the result. We're not talking about some vague buzzing sensation. No way. In clinical trials, users can close their eyes and tell the difference between textures like sandpaper and silk. They can feel the shape of a grape or sense the exact moment an object starts to slip and then instinctively tighten their grip. It's a real, intuitive, functional sense of touch, completely restored. But creating this rich sensory feedback is just one piece of the puzzle. To be truly intuitive, the limb also has to move just as seamlessly.
And this is where the second major breakthrough comes into play: artificial intelligence. AI is what's transforming these clunky robotic movements into fluid actions that happen literally with the speed of thought. Let's see how this builds on what we've just learned.
Now, the contrast here is what's really interesting. Traditional prosthetics, they read simple muscle twitches to do very basic things like open hand or close hand. It was slow, it was limiting. But AI-driven bionics, it's a whole new world. They use machine learning to analyze these complex patterns of muscle signals, predicting what the user intends to do in real time. The system learns you and helps you do what you want to do, fluidly.
Just think about this number for a second. 500 times per second. That's how fast the osseur proprio foot, which is a powered ankle, adapts to a changing environment. This means that as someone walks from, say, pavement to grass or up a flight of stairs, the AI is constantly making these tiny micro-adjustments to make sure their gait is smooth and natural. Users actually report that they just forget they're even wearing it. That's the power of AI.
And this kind of capability leads to moments that were once, honestly, considered completely impossible. Using the advanced Luke arm, one patient was actually able to play the piano. Just think about the dexterity that requires, the precise pressure, the individual finger control. It's a task that demands a near-perfect union of your intention, your movement, and the feedback you get.
And the real cutting edge, the next frontier, is brain-computer interfaces, or BCIs. With these, electrodes are implanted directly on the brain to read motor signals and send sensory data back. So the crucial thing here is that this closes the loop. Thought directly causes movement, which creates a sensation, which then refines the next thought. The machine is no longer a tool you're operating, it's becoming a physical part of your own neural wiring.
The science behind all this is obviously incredible. But the real story isn't just about the advanced surgery or the clever algorithms, it's about how these breakthroughs are fundamentally changing what it means to live with limb loss. So let's just ask that question directly.
Beyond all the impressive specs and the cool tech, what does this truly change for someone? What does it actually give them back?
The answer is their life. This technology gives people their lives back. It dramatically reduces chronic, agonizing pain. The psychological benefits are huge. We're seeing lower rates of depression. People can get back to work, get back to their hobbies, and maybe most importantly, it restores intimacy. The ability to feel the touch of a loved one without being afraid of hurting them with a piece of unfeeling metal, that is truly life-changing.
And one of the single most significant impacts is on a condition called phantom limb pain. This is a very real, often debilitating pain that feels like it's coming from the missing limb because the brain's sensory map is still totally active. And get this, a staggering 80% of amputees suffer from it. By giving the brain real, meaningful feedback from the prosthetic, this tech can dramatically reduce that suffering. It gives the brain the signals it's been craving.
So the trajectory here is clear, and it's incredibly promising, but it's not without its challenges. As we look to the future, we have to consider not only the practical hurdles, but also some of the deeper questions this technology raises about who we are.
The most immediate barrier is, you guessed it, cost. The price tag for a state-of-the-art bionic arm can be over $100,000. That puts it out of reach for so many people. And insurance coverage, well, it's still trying to catch up to how fast this is all moving.
And there are other hurdles too. Engineers are constantly working to improve battery life and just make these devices tougher for everyday use. And for the most advanced systems, we're still figuring out the long-term safety of implanted electrodes and how to manage the risks of these really complex surgeries.
But when you get beyond all the practical stuff, this technology forces us to confront a really fundamental idea. When a machine can feel, when it moves according to our will, that clear line we used to draw between our bodies and our tools, it starts to get pretty blurry.
And that leaves us with this final question. When a prosthesis is no longer just a substitute, but a sensory-rich, intuitive extension of our own nervous system, what does that say about the future of our identity? It's a question that takes us way beyond the realm of science fiction and right into the very definition of what it means to be human.